Today's lesson is about how to solve trig inequalities. For A, 2 cosine x over 2 plus 1 less than 0. X is greater than 0, less than 6 pi. First of all, since this is a linear inequality, we need to isolate the cosine x over 2. Move 1 to the right side, so you have 2 cosine x over 2 less than -1. Then we divide it by 2 both sides. Remember the rule for inequality. We will use this mommy, daddy, nanny. Multiply divided by negative number. We need to switch the symbol for linear inequality. Since we divided by +2 both sides, symbol stay. Reduce, you will get cosine x over 2 less than -1 over 2. This is the one we got to use to sketch the graph later on. So this is the first step. Second step, we need to solve equation cosine x over 2 equals -1 over 2. Because the domain is x greater than 0, less than 6 pi. So we need to draw the diagram is between 0 and 3 pi. This is 0, pi, 2 pi, 3 pi. Start from this 0, stop at 3 pi. And this is 1, 2, 3, 4. All students take a calculus. For this equation, since this is a -1 over 2, it will go to quadrant 2 and 3. And we know the reference angle is pi over 3, which means it's 60 degrees. We only need to write down the pattern for second and the third quadrant. For second quadrant, we have n minus 1 pi over n. We have 3n minus 1 pi over n. For third quadrant, we have n plus 1 pi over n. So we will plug in n equals 3 to this 3 pattern. You will get x over 2 equals 2 pi over 3, 8 pi over 3, and 4 pi over 3. Multiply by 2, you will get the x equals 4 pi over 3, 16 pi over 3, and 8 pi over 3. Then the third step, we need to sketch the graph for this one. Y equals cosine x over 2. We know the period equals 2 pi over b. The coefficient of x is b, that is 1 over 2. So we have 2 pi over 1 over 2 equals 4 pi. So we sketch the graph. This is 4 pi. So half, half, half. Amplitude is 1. For positive cosine x, the pattern is this. We need to figure out 1, 2, 3, 4, 5. Therefore, we get 1, 2, 3, 4, 5. This is a 2 pi. Half of 2 pi is a pi. So we get this is a 5 pi, 6 pi. Remember, the domain for this inequality is between 0 and 6 pi. That's the reason I go to this 6 pi. Then we keep this pattern, go down and go down. The graph will be like this. Then we need to sketch the graph for y equals -1/2. For y equals -1/2, so here's a -1/2. Let's draw this line. You could say you get 3 intersections. These 3 intersections will be these 3 solutions. So you could say this is a 4 pi over 3. This is a 8 pi over 3. And this is a 16 pi over 3. Then check here is less than -1/2, which means below this y equals -1/2, which means this part of the graph will be the solution. So we can write down the solution like this. Since no equal sign, this will be open parentheses. You can use inequality to write down the solution, or you can use interval notation. For inequality, you can write down x greater than 4 pi over 3 less than 8 pi over 3, and x greater than 16 pi over 3 less than 6 pi. Or you can use interval notation. That is open parentheses, 4 pi over 3, 8 pi over 3, union set with 16 pi over 3, 6 pi. Let's go to B. 2 sine x over 2 minus square root of 3 greater than 0. X is greater than equal to 0, less than equal to 6 pi. Since this is a linear inequalities, we still need to isolate sine x over 2 on one side. So we move negative square root of 3 to the right side. You will get 2 sine x over 2 greater than square root of 3. Then we divide it by 2 both sides. Because we divided by positive number, the symbol stay still greater than. Reduce, we get sine x over 2 greater than square root of 3 over 2. This is the first step. Second step, we need to solve sine x over 2 equals square root of 3 over 2. Square root of 3 over 2 is a positive. So go to the first and second quadrant. The reference angle is 60 degrees. That is pi over 3. We know the domain is between 0 and 6 pi. So x over 2 will be between 0 and 3 pi. Draw the diagram. So start from 0, stop at 3 pi. We only need to write down the pattern in the quadrant 1 and 2. For quadrant 1, we get pi over n, and 2n plus 1 pi over n. For second quadrant, we get n minus 1 pi over n, and 3n minus 1 pi over n. Therefore, when n equals 3, we plug into this for pattern, you will get a solution for x over 2 equals pi over 3, 7 pi over 3, 2 pi over 3, and 8 pi over 3. Multiply by 2, you will get x equals 2 pi over 3, 14 pi over 3, 4 pi over 3, and 16 pi over 3. This is the solution to this equation. Third step, you need to draw y equals sine x over 2 and y equals the square root of 3 over 2. So for y equals sine x over 2, we know the period is 2 pi over b. b is 1 over 2. You get 4 pi. Pattern for sine x is this. We need 1, 2, 3, 4, 5. We need these 5 points. Let's sketch the graph. This is 4 pi. Half, half, half. Amplitude is 1. Here's a -1. So you have 1, 2, 3, 4, 5. This is 2 pi. Half of 2 pi is pi. We know the domain for this inequality x is between 0 and 6 pi. So we have 5 pi, 6 pi. Keep this pattern. You will get this. So let's sketch this graph. Then we need to draw y equals square root of 3 over 2. This graph. Square root of 3 is 1.732 divided by 2. It's round to 0.8 something. So 0.8, we assume here, we will draw like this. You will get 4 intersection. This is y equals square root of 3 over 2. This 4 intersection will be these 4 solutions. So you have 2 pi over 3. This is 4 pi over 3. 14 pi over 3 and 16 pi over 3. Check the inequality symbol. Greater than square root of 3 over 2 means above y equals square root of 3 over 2. So this one and this part is the solution. For the inequality, this is a no equal sign. So this is an open circle. Therefore, we can write down the solution like this. Let's use the interval notation. 2 pi over 3, 4 pi over 3, union with 14 pi over 3, 16 pi over 3. This will be the solution to the inequalities.